Hi people. The previous video we shot was based on Spider-Man adhesion ability, which was really nice. We talked about some interesting stuff related to quantum mechanics and things about physics, how it explains it. And I enjoyed that video, and I hope so you also enjoyed that quite well. And due to that, we are going to do some more interesting things today. And I think I did somewhat of justice to that video. So I think I would continue such kind of things, which is very interesting and it directly correlates physics with imagination, actually, which we see in movies and stuff. And now let's continue to our video, which we are gonna do today, and that relates to something which is very interesting and was in uh, frequently in my mind to shoot that, and it was recently, I love movies, right? I love movies, I love comics, I love science fiction books, I love everything about science and science fiction, mystery, and basically it's about films. And recently, I watched a movie which was Project Hail Mary. I was fortunate enough to watch it in theaters actually, and I enjoyed it a quite lot. It was a science fiction story, but at the heart of it, it was emotion based on friends, you could say. The context is that those friends are not from the same city, not from the same state, not from the same planet. They are of different planet, even different star system. So the story goes like a scientist whose name is Ryland Grace. He is on an unknown mission. I mean, a thing called a virus called astrophase is it is a very dangerous virus which is eating the sun fuel. I mean, it is literally making the sun die. So he have to go to a distant star system, which is Tau Ceti star system, and bring something called Tamiba, which could possibly kill the astrophase, or neutralize the astrophase, and don't let them eat the star. I mean the fuel of the star. So the whole Earth doesn't come to ice age and we won't die. So the story is interesting. The premise is interesting of Project Hail Mary. But the thing is, uh, in that the scientist, or you can say Ryland Grace, when he goes to that star system, he also encounters an entity or other species who is completely made up of rocks. The main material they possess is xeronite, and they bond each other. They solve the same problem, helping each other, because the guy which the other species whose name was Rocky, he has also come for the same purpose to save his own star system, to retrieve this Tamiba and neutralize this astrophase, because they are killing all the star system around the universe. So the interesting thing is, when they communicate for the first time, it was very interesting because Ryland Grace uses some technology, some AI, some physics, anything like that, to communicate with that different species which is Rocky, and they bond together by understanding each other through that system of communication, which is possible because of science basically. And that intrigued me, that fascinated me, that how they did it. And I was aware of some stuff that how they did it. And today our topic is wholly based on that concept, that how Ryland Grace as a scientist was able to talk to another species who is not talking English. They are very different species, they have very different culture, grammar, vocabulary, everything. But still, Ryland Grace was able to contact with him, or able to talk with him, communicate with him without any uh, knowledge of their grammar, vocabulary, anything. Just because he understood physics, just because he understood the physical structure of the thing he is speaking, or the thing he is trying to communicate, the underlying physical reality, which is very important to understand. And today, the whole video is based on that idea that Ryland Grace, the scientist, is trying to understand the physical reality of what he is getting from Rocky, not the actual language or grammar or words actually, but the physical reality beneath that, that how he process that information by using the physical laws, which doesn't change by changing the places. Just think it like that, that you encounter an extraterrestrial organism or extraterrestrial civilization who is trying to communicate with you, but how would you try to understand them, or how would you understand them, or how would you communicate with them? Just think about that. So the basic principle lies in understanding what are they trying to communicate. I mean, the basic principle is not to understand that what they are trying to communicate, but the thing they are trying to communicate, is it something which is made up of the same physical law we are following? And obviously it would be. So we have to understand the underlying structure beneath that information, that what is it made of or what is it based upon. So if we understand that physical reality, mathematical reality beneath that information, we could possibly understand what they are trying to communicate further, and which will be very beneficial for an two civilization who are of different species, different planet, different star system. By communicating each other, they could exchange ideas. They could, I mean, possibly take the whole fate of universe to a different level, which is very interesting. So my whole video is based today on that concept, that how do we understand an alien language? Alien is something we don't understand. They are beyond our process of thinking. So suppose if we encounter such a civilization, such an recognizable signal, then how would we proceed with it? It is a very difficult situation. But as a physicist, I mean, I'm not still a physicist, but a student of physics. So as a student of physics or as a physicist, how would he think about that problem? That how would he try to understand those civilization, those people, those species? What should be his first steps in understanding their language or understanding their, behavior, anything they are trying to communicate? So what should he do to get straight to it? So our whole video is based on that, that how do we understand something very alien? How do we try to communicate with them? What are the first steps that we should follow, which is based on very physical reality of universe, which is very mathematical, but not based on words or translation or English or anything. It is visual things, but the underlining important and very detailed or very deep thing is the mathematical structure and physical laws that following it, the physical reality or physical situation beneath it. I mean, I am trying to give you an idea that what we are trying to do today, and the thing which is the everything that I will be going to say to you today or will figure out today is already mentioned in the description with a PDF which is very detailed, and I have made it with complete heart. It is actually very detailed and very good. You can say it is better than previous also. From the previous video you saw a PDF, it is better than that also. I have understand the complete mechanism. How would we try to understand that language or try to understand that alien signal or information that we are receiving? And so if you want to study that, you can go directly and read that, and you could possibly follow the video with it, so you could get a better understanding that what I am trying to say to you or what I am trying to communicate with you or my insights and everything. You could basically relate that, and you could prefer it side by side, try to learn it side by side, or get educated with it. Yeah. So you could follow that PDF. It is completely free. I have pasted the link in the description with the drive, and it was a very challenging thing to do. It was a challenging project, but I enjoyed it. I enjoyed it thoroughly, doing everything I could and concise hold the information in a story form, which will be very interesting for you to watch. And so now let's try to understand if the way I'm communicating with you, if the alien civilization try to communicate the same thing with you, then how would you try to understand that information or communication or signal or anything? So let's get to it and be educated on that. Yeah. So before getting straight to the mathematical part and the writing part, I would like to convey to you something that think of like that one day humanity is getting struck with some signal from a extraterrestrial civilization which is not familiar. Then how would we deal with it? Because it is important to understand, right? Because if someone tries to communicate with us, we try to understand them. So we need to understand them. What we need to understand what they are trying to communicate with us. It's a very basic thing we need to do. So the first step when we get a signal or some type of communication they are trying to do with us, we basically receive a signal from our from our receiver. They transmit something, and from the receiver, any kind of receiver, we receive that. Okay. So it is done through radio astronomy, or if you take the example of the Project Hail Mary story. So the scientists Ryland Grace and Rocky is face to face. They are I mean, in a direct communication contact. So Rocky can say things to him and he could record that with a microphone. So you can take this case, or we receive something from radio waves. I mean, our radio astronomy, we receive that. I'm not familiar with the astrophysics kind of thing, but suppose we receive a signal through something, then possibly we would like to understand what that is trying to convey us. Yeah. So when we receive that, we understand something which is, before getting to the information part of it, like before understanding what the signal is trying to communicate, or what message it is trying to tell us, or what information that it has, which we need to understand, before everything before everything this, we need to understand what is the physical nature of that signal which is getting. You try to understand what I'm saying? You are getting what I'm saying? The thing is, before understanding what the signal is comprised of or made of, or what physical phenomenon by which the signal has been carried through, before understanding that, we will not get straight or direct part to which through which we understand that signal, or what that signal is trying to say us. So before doing everything this, before understanding the physical nature or the physical phenomenon by which it is being carried, we cannot get straight to the message part of what it is trying to tell us. It is very difficult. So the first thing first, we need to understand that what physical phenomenon is carrying that signal, or what physical nature it is hiding beneath it. We need to understand that, which will be done through physics and mathematics. I mean, I like to give an example. When we speak something, that information is transported through sound waves, right? The pressure variations in the atomic level of the air molecules, through which our sound is getting transmitted from one receiver, one object to another object. Simple. And things like light and various things, various message in space is transmitted through electromagnetic wave or electromagnetic radiation. So these are kind of physical phenomena which drive that signal, or which drive that message. So before understanding the message of the extraterrestrial organism which they are trying to tell us, before understanding that core message of what it is trying to tell, we must first understand what is the physical phenomenon that is driving that, or what is the physical nature of the signal which we are getting. Simple. Now let's get straight back to the explanations part. Okay, thank you. So now we try to understand that when, which we talked about, when we receive a signal, scientists receive a signal, right? I mean, the signal doesn't look exactly like this, but when we receive a signal, we don't try to understand its meaning first. I mean, the meaning or the information part of it, we don't get straight directly to this. We goes to the thing like understanding what it is made of. I mean, the signal which we receive, we try to understand its structure. I mean, we try to understand the underlying structure of it, which is very important. Which is important. I mean, physics literally talks about this. Like, try to understand that when we talk about electromagnetic field, EM field, or vibration or oscillations of a string, in this phenomenon, we don't try to understand exactly. I mean, these are some physical systems, right, in physics, and the objective is same here, that we try to understand what are the fundamental components upon which this observed phenomenon we see, that is the vibration or oscillation of an electromagnetic field or of a string, what fundamental components due to which this observed phenomenon are built. We try to understand the underlying structure from which, like I would like to give an example that an EM field looks like this, which you all know. One is your magnetic field and another is your electric field. And they vibrate in the direction of propagation. So we try to understand this electric field, magnetic field, and direction of propagation, through which we understand the electromagnetic field. So we try to understand the structure of it, which leads to the EM field observation or the EM field phenomenon, which we later see. So first of all, we think about the structure, then we goes to the phenomenon. Right here, the signal we receive, the information part or the meaning part is right now not important, but the structure part is more important than that. So we jump directly to understanding the structure of it, not the information part. Okay. So the important thing is here to understand that I said some term which is called oscillations here. You heard it right. Oscillations. So these terms I use, or the term I use, this will be very important in understanding the further coming part about this problem or about this project you are trying to do. Because oscillation is something which is very basic to the nature. I mean, it is very natural to the nature. Like, try to understand this. A stretched string, if you plug from one place, what it's do? It vibrates, right? It vibrates. Vibration is nothing but some kind of oscillation. I mean, air molecules in the air, they oscillate when we speak something due to pressure variations. That is some kind of oscillation we see in nature. Like I told you right now that electric and magnetic field, they oscillate to produce an electromagnetic wave. I mean, in quantum mechanics, the wave functions you see, they are literally the thing which evolved by using the oscillatory functions. Like you have seen this, e to the power minus I h t by h bar psi 0 t. So this equation you see, in which an state function in quantum mechanics, it literally evolved with a oscillatory phase. I mean, oscillation is nearly embedded naturally in universe or in nature, you could say. Oscillation we talk about, these are very important things. We need to understand that oscillations are not something which, it is not something very abstract. It is naturally in universe. It is very core thing of nature we see, oscillations. It is very evident in many phenomena we see in our daily lives. In thermal motion, you can say. In a thermal motion, when in atoms and molecules, they also somewhat do oscillations. Vibration and oscillation. This collective vibration of all the atoms, this lead to thermal motion, right? And thermal motion leads to temperature. So all this phenomenon, it includes some kind of oscillation, some kind of vibration. So it is rightly said that the signal which we receive, it is also made up of some kind of oscillations. The signal which we receive, it is also a very idea that the signal itself also obey the universal laws which governs the waves and oscillations. The signal similarly should obey that oscillation is a very core thing of nature. So signal is not deprived of that. The signal which you receive from an alien world is also based on the same physical laws and physical phenomenon which is based on oscillations. So the signal tries to convey us some message which is now rightly unknown, and we have no mean to understand that because it is based on a different culture, based on a different phenomenon, based on different linguistics vocabulary. But the construction of it, the structure of the signal doesn't begin with the language but begins with the oscillation part of it. Because you could see that oscillations are the basic thing which describes a wave, and by the wave I mean a signal. So the signal we are receiving, that is basically described by an oscillation. So oscillation is the very nature of a signal which we receive. If we try to study the signal which we are receiving, we cannot possibly ignore the oscillation part of it. I'm clear here? Okay. So the next part is very crucial here. I will just give a brief review that the signal we receive, we need to understand its structure, but not the meaning first. We need to understand what is the structure behind it. What is the structure beside or beneath the phenomenon. So we took here some example, the thermal motion, the vibration, the QM state. All this phenomenon, it has oscillation related to its structure. Oscillation is the very basic idea of their structure. So oscillations are something which is engraved in it, which is very basic to understand. So to understand the signal, which is some kind of wave, and wave are naturally governed by oscillations. So we need to understand what are oscillations to get a very idea of the signal we are trying to study. So, here we represent an idea or introduce an idea which is not called, but which goes like this, that Let us take a physical system. Physical system, yeah. And you understand that a physical system is defined by some mathematical description. Am I correct? In physics, you know that every physical system, is represented by a Hamiltonian, and it is written in some mathematical form. So you agree with me that every physical system has some mathematical description related to it. And you know also that the physical system could have multiple mathematical description. Like I would like to give you an example. Think about quantum mechanics. In quantum mechanics, there are many mathematical description. Be it the matrix mechanics, be it the Dirac, Bra, and Ket notations through which you understand quantum mechanics, and be it the Schrodinger wave mechanics through which you understand quantum mechanics. So there are multiple mathematical description that explain a physical phenomenon or a physical system or a complete theoretical domain of physics, right? If we become more specified than that, we can understand that a particle, it is going somewhere, and the trajectory it says us, the trajectory of the particle or the path of the particle, it could be described by position and momentum both. You agree with me? It could be plotted in position space as well as in momentum space. The mathematical description are different, but it is making us understand the same physical system here. If we take more example than an electromagnetic field we talked about here. An electromagnetic field can be understood both in time domain as well as frequency domain. It is basically content of waves, right? And waves could have both, with respect to time, they could have some amplitudes, and with respect to frequency, they could have some amplitude, right? So frequency and time domain both could explain the electromagnetic field very well. So this both different mathematical description also explain the same physical system. Like I talked about quantum mechanics, we could also talk about the quantum states. Quantum states, yeah. Quantum state, as we know, is a state which describes a quantum particle. A particle which is very small, and a quantum state describes it very well. So to understand a quantum state here, we could apply or we could use many mathematical description like energy eigenstates, momentum eigenstates, or position eigenstates. Any of this. We could use any of them. By looking at its eigenvalues, we could possibly study the states by any of this mathematical description. But still it is representing the same physical state. Right? Yeah. So understanding the fundamental is something which is related to mathematics, right? We have to understand the math behind it. But the math is very different. It could be multiple maths. So the thing which I'm trying to convey here is the physical system is the same. But to understand that physical system, we have many mathematical description. So we need to catch that exact mathematical description through which we get the ideas which we need. Like we are trying to understand the very physical idea, which is oscillation here. We need to understand the oscillation in the signal, because oscillation is the very basic thing we start with. Because oscillation will give us the possible answers to understand the structure of the signal, because oscillation is the basic structure. It is the fundamental thing which is related to the structure. So to get the oscillation from the system, the signal is a system, right? It is a physical system. To get the oscillation from the system or from the signal, we need to get that mathematical description precisely to get the oscillation part of it completely out. You try to understand what I'm saying? To get that mathematical description out, to understand the oscillation, we need a mathematical framework which is able to, reveal the oscillatory components hidden within the signal. To understand the oscillatory components which is hidden within the signal, we need a proper mathematical description that exactly take out that information from the signal. And that mathematical framework which does that, which is able to extract the oscillatory information from the signal, is called Fourier analysis. which is the most important term you would see in this video. Fourier analysis is something we do, which is a mathematical description, nothing more than that. It is a mathematical description of a physical system, and that physical system is a signal or a wave, which help us to extract out the oscillatory components hidden within that signal. And by getting that oscillatory components from that signal, we would understand the structure with which the signal is comprised of, or the physical phenomenon through which the signal is getting transferred with or communicated with. Am I clear here? Fourier analysis here is not merely a topic of mathematical physics, but it is something which help us to understand that very interesting question we begin with, that how do we interpret an alien signal? This alien signal which we are not able to interpret, this is answered by such a simple mathematical description, which is Fourier analysis, that completely relates to the physical system we are trying to study by studying the structure, which is oscillation. Fair? Okay, now come a very important question, which is the choice of the signal. I mean, why is this question important? First, let us understand that. I mean, see, the signal which we receive from alien civilization or extraterrestrial civilization, it should be carried by some physical phenomenon, right? I mean, it should be carried by some carrier. I mean, if I try to give an example, a sound is carried through some medium. An electromagnetic wave doesn't require a medium. It goes without a medium. So the medium is very important through which it is being carried. The nature of that medium is very crucial. You try what I'm trying to say? Yeah. So the signal which we are receiving, its physical nature is very important to clear it right now, because we are going to go very specific doing that. However, whatever physical nature we decide of that carrier, I mean, the physical nature could be EM signal, it could be an EM signal, it could be a sound signal or an acoustic signal. Acoustic, you understand, it is based on sound. So the acoustic signal or sound signal or EM signal or an optical signal, it could be anything. It could be anything of such. Its physical nature can be anything. Through the physical nature of carrier can be anything. Basically, the signal is carrying some information, some meaning. So the carrier of that meaning can be anything. It could be a sound signal, it could be an EM signal, it could be an optical signal. But the important thing is that any of the signal you take, the mathematics behind it or the mathematical framework remains the same. We could apply the same mathematical framework to any of this signal, any of this physical nature of the carrier signal. We could apply the same mathematical framework to any of the signal we take. Any of the signal whose carrier may be different we take. We could apply the same mathematical framework everywhere. So the signal depends on what receiver we are deciding. Like if we receive something through radio antenna, it is a radio signal. If we receive something from optical photo detector, then it is an optical signal. If we receive something from microphone, it is an acoustic signal or a sound signal. The very important thing which depends upon that mathematical framework we are trying to do, or the very important thing which is important for the mathematical physics part of it, is the x of t. Now, what is this x of t? See, any signal we receive, it should define a measurable quantity. It should define a measurable quantity which varies with time. Try to understand this straight. We receive a signal, it has some structure, it has some information. So before trying to understand the structure and meaning of it, first we need to understand that what is this x of t. So see, it is a quantity which depends upon time. So the signal which we are trying to receive, which we received actually through a radio antenna or an optical photo detector or a microphone or any other sensing device, it should give us some mathematical function. So we could, observe it through some mathematics, through some mathematical framework. And that mathematical function is this function, which depends upon time, that x of t. And this x of t is only the important part here. It doesn't depend upon the thing that it is a EM signal or a sound signal or acoustic signal or optical signal. It doesn't depend on that. The important thing is any of this signal, there has to be some mathematical function we need to observe through this mathematical framework to reveal the structure of the signal. So this mathematical function is important, but not the nature of the signal we are receiving. That's it. Understood? I think I'm clear here. And once we understand what is this mathematical function or what is this quantity, what is this measurable quantity we are trying to understand, which depends upon time, we could basically understand the oscillation inside the signal, which directly connects to the structure of the signal. Am I clear here? Okay. And I also want to tell you that we are going to select a specific signal before proceeding further in this video, that is our acoustic signal or the sound signal. Why I am trying to do so, why I am selecting this, I will tell you. So I am selecting this acoustic signal or the sound signal for two specific reasons. The first reason is acoustic signal or the sound signal. See, sound is something which is very imaginative, is very intuitive to understand. It is very intuitive. I mean, sound can be visualized very easily. Which is the first standard you studied about sound? It was 9th standard, right? So sound is a very intuitive thing which we could understand very easily. Am I correct here, guys? Sound is something we could easily understand. I mean, the visualization of sound is very fundamental. I mean, like see, we are trying to study here oscillation. I mean, oscillation is the very fundamental thing which reveals the structure because oscillation is fundamental to nature. So sound is something which is very fundamentally oscillatory physical phenomenon. I mean, the very basic oscillatory physical phenomenon you could understand, that is sound. It is comprised of compression and rarefaction, right? Which you studied in class 9th. So it is something like oscillation in nature, which is an oscillatory physical phenomenon. And its mathematics, its underlying mathematics is also easily visualized naturally. I mean, you could visualize it naturally very easily. So it is an important and fundamental oscillatory physical phenomenon that we could intuitively understand very easily. That is the sound. And also the mathematical structure lying beneath it is also very simple. So it is a, obvious choice that we select the acoustic signal to build a physical model which explains the structure of the signal. Because by taking a easier thing, not easier, but a comparatively easier thing to visualize. I mean, if you take this as our physical nature of the signal, then we will understand the mathematical framework relatively easily or comparatively easily if we consider an EM signal or an optical signal, because they have specific nature and that nature governs some specific laws. So if you take the simplest one, that is the acoustic signal, we could straight out describe the mathematical framework in an easy way. This is our first reason why we selected the sound signal. The second reason is that we were talking here about the project Hail Mary. Like the way I described you. In this movie, Rocky and Grace, they talk to each other directly. I mean, Rocky and Grace are in a far distant star system and they meet and they talk to each other far directly. So Grace could directly record Rocky's voice in a microphone. That means there present some kind of medium. I mean, in that film, Rocky built a specific kind of container in which Grace could walk and meet him. I mean, between their ships. So there present the air which Grace could breathe. So there present the air molecules. So whatever Rocky speaks, Grace could hear it directly. So he could capture that in a sensor which is nothing but a microphone. That means it is specifically an acoustic signal that Rocky is sending to Grace. So it is an obvious choice that we take the signal as an acoustic signal as the physical nature of the signal here to understand the mathematical framework a little bit easier. So our questions become very specific now that the unknown signal which we receive is nothing but an acoustic signal. And that acoustic signal we have to analyze the structure as a physicist which will become our first step. Okay. So we will now understand this physical structure of an acoustic signal which we are receiving from an alien civilization with the help of mathematical physics, with the help of Fourier analysis, and understand its structure, understand what it is based upon, that is oscillation. And oscillation is it is the very physical fundamental thing in nature, and the structure is directly proportional to the understanding the oscillations there. And once we do that, we understand the structure and hence the meaning. Okay, so we looked upon the fact that whatever physical nature of the carrier we take, the alien civilization, they will not deliberately select the signal as sound signal or EM signal or sound signal, optical signal. They could send the signal in any form. They could send the signal in any nature. But the important thing to understand here is any signal they send, the important thing here is x of t. That the signal will provide us a mathematical measurable quantity which varies with time, that will help us understand the very nature of that signal, or it will be the subject of Fourier analysis. It will be a thing which will be studied through Fourier analysis, not the actual signal or the nature of the carrier of the signal. That could be anything, but the thing which it provides us, or the thing which the receiver receives, is this, the mathematical quantity that changes with time. And that quantity is the direct subject of the Fourier analysis we are trying to do. And that gives the nature of the signal. That's what I'm trying to say. And after that, now we understand what is the sound in its purest form. So, as you know from the lower classes, the sound is nothing but compressions and rarefactions. You have heard this basic definition, right? These are nothing but rarefaction and compression. So, how does this rarefaction and compression happens? Like when a speaker speaks something, a radio or a speaker, it emits an acoustic wave, right? It's emit a sound wave. So that sound wave, what it do is, the particle present in the atmosphere or air molecules, they get some energy from it, and due to that energy, they will oscillate around that equilibrium position. As you know, an oscillation happens when there is an equilibrium position, and that oscillation happens around that equilibrium position. So we fairly understand that equilibrium position help us to visualize that oscillation. And when that oscillation happens, the air molecules transfer that energy from one particle to another particle. And that's how that disturbance that is get carried from one place to another place. This is an A point, this is a B point. So the disturbance get carried here to here through the energy transfer through the molecules. And that molecules, they oscillates about their mean position or their equilibrium position, and they transfer the energy from one part to another part. Now, you could possibly imagine that here the pressure is more and here the pressure is less. So in a compression, the pressure in the atmosphere is more, or the air molecules is more, and in a rarefaction region, the pressure is less. So you could understand here that there is some pressure fluctuation. What is it? There is some pressure fluctuations going on when we send a acoustic wave, or when we send a sound wave. When we send a sound wave, there is some pressure fluctuations which is going on. Around the equilibrium value, that is P naught, that is atmospheric pressure, there is change in the pressure of the atmosphere around us when we transmit an acoustic signal, because there is oscillation, there is rise in energy, and there is oscillation around the equilibrium value which is getting transferred. So the pressure fluctuations is different in different region. That's why we could explain it by a equation which is P of RT equal to P naught plus del P R of T. According to the space and time, we could specify that there is pressure different in different region, like we see here. That means there exists a pressure fluctuation when we send a acoustic wave in a medium. I mean, it is clear that sound requires a medium to travel. EM wave doesn't require a medium to travel because sound transmit the disturbance from one particle to another particle in a medium. That's why. So we could understand that there is some kind of pressure variation which is produced by propagating acoustic wave. That's clear. Now if we see the microphone as a detector here. When we see the microphone as the detector here. So the microphone receive this pressure fluctuation with respect to the P naught, which is the atmospheric pressure. So there is a difference between atmospheric pressure and the pressure he receives at the surface of the microphone in which he receives the disturbance. So the microphone basically receives the pressure fluctuation. And as the microphone, I mean the diagram is not so good, but this is the microphone. And in the base of this microphone, this base is constant, right? So there is no R component which is changing of the pressure fluctuations that this microphone encounter. There is only change in the time component. I mean the microphone is fixed here. So the pressure fluctuation it will receive only depend upon the time of the acoustic wave through which it is getting transmitted. It differentiates between the atmospheric pressure and the pressure in the surface which when it receives the acoustic signal, and there will be some fluctuations here. So the fluctuation it receives is basically this in the microphone. Okay, and the microphone converts this pressure fluctuation into some electrical voltage inside it. And that electrical voltage is studied as this quantity, which is x of t, which depends upon time, which is the measurable quantity or which is the mathematical measurable quantity, which is the direct subject of Fourier analysis, which we do to understand the structure of the acoustic signal or the sound signal. You get it? There is some pressure fluctuation, and that pressure fluctuations is directly measured through the microphone, and that microphone translates it to electrical voltage, and that electrical voltage is interpreted as x of t, which x of t is studied under Fourier analysis to understand the structure of the acoustic signal or the alien signal we are receiving. I mean, up to this point you are clear, I think, that what is going on here, what is going on with the signal, what it is made up of, why deliberately we choose the signal is made up of oscillation, why is it a natural choice. To understand oscillation we require a mathematical description. Why Fourier analysis is a natural choice is still not clear, but Fourier analysis is some mathematical description which gives the better idea of the oscillatory part of signals, and the oscillatory part of signal is better interpreted when we take the sound signal as the better example, because it is intuitive and the mathematical structure is simple. And also the project Hail Mary inspiration, which let us take this sound signal as acoustic signal. Up to this point, I think you are clear. Let's clear something, which is, x of t now. The x of t is nothing but it is the electrical voltage which is received in the microphone. Now, if I write the x of t a little mathematically, you understand that x of t is nothing but the pressure fluctuations at a specific time. Space we ignore because the microphone is constant and it is fixed. And this del of Pt can be written as P at a specific time minus P naught. P naught is the original atmospheric pressure, and these two quantities are compared to get that pressure fluctuation, which is directly recorded as electrical voltage in a microphone, interpreted as electrical voltage in a microphone, which is then studied as a quantity which varies with time, and that is the thing which we study in Fourier analysis to understand the structure. Now we can interpret this x of t a little better mathematically or graphically. Like, you could understand that this x of t is nothing but, with respect to the time axis, this x of t only gives us the amplitude. It only gives us the amplitude, some kind of amplitude depending upon the time we select. I mean, according to the time we select here, according to the not select, but accordingly the time passes, it gives us the amplitude of the signal which we receive. That's it. To better understand the pressure variation or x of t here, you could directly refer to the PDF I have mentioned in the description, which gives a better idea of that how the microphone interpret the x of t, or what are the values with changing in time. I will give you here a screenshot to understand what is x of t better. Okay. there is an important thing which you could notice here, that this thing, this x of t, is in time domain. I mean, this is evident, pretty evident, you could see. And time domain is not a bad thing. We are getting the amplitude of the signal which you are receiving with respect to the time. That is fine, okay. But what is the limitation of this picture? Let me give you an example. If there are two musical notes, you could see the frequency difference here. Frequency is a not term I have is a term which I have not still introduced or appreciated. So these two musical notes, when they are played together, so the x of t which we record through this signal, through the microphone which we record, the time dependent measurable quantity which we record, it never reveals us that waveform which we now have, which have some values x of t, it contain two different oscillation or two different waveform with different oscillation. It has a different oscillation structure. It has a different oscillation structure. So the waveform which we now have, that is x of t, which is of basically time domain, that rarely reveals us that x of t contain information which is submerged or which is comprised or which is added by two independent oscillatory structures or two independent oscillatory functions or two independent oscillatory waveforms. So it will just mix it all. Now, how are you so sure that alien civilization which transmits such a complex acoustic signal, it would only comprise of a single oscillatory structure? I mean, it is very impossible, right? The very impossible word is engraved in that a complex acoustic signal would contain only one oscillatory signal. It would basically contain thousands of them. I mean, trillions, billions of them. So how do you separate them? It is very difficult, right? I could see the very pain in your mind that how would we differentiate them? So the time domain picture is not at all sufficient to do that. It is not at all sufficient to understand the difference between this oscillatory structure that is present in your waveform. So we need to not limit ourselves to this time domain and move to a domain or a mathematical description which will be appropriate and more familiarly reveal the oscillatory information hidden behind the signal. Nevertheless, we understood a very interesting thing here. I mean, just look at a signal. What is a signal? It is a combination of small, pure oscillations. I mean, the oscillations can be different. But think of it like that. A signal can be made up of similar pure oscillations. I mean, elementary oscillations. I mean, elementary oscillation 1 plus elementary oscillation 2 plus elementary oscillation 3 ... This could all add to a signal which we are getting transmitted to an aliens organization or alien civilization. So this elementary oscillations could directly combine and give us that signal. So the thing is, this time domain doesn't differentiate between these things, but it also represents an important structure that a acoustic signal, a complex acoustic signal we receive can be a combination of such elementary oscillatory blocks, and which is very important to understand the further discussion we are having through this topic. But before going to that, we need to understand what is a pure oscillation. Because if you understand what is a pure oscillation, we could basically reveal this oscillatory structure hidden behind it, getting added, giving that signal. So if you understand that pure oscillation, we understand in each individual oscillation it is made up of. And if you understand this each oscillation it is made up of, we get each oscillation, each oscillatory structure, and individually getting that, we somehow deformed, or I mean, it is separated to different oscillatory structure, and we examine that structure in a more broader way, revealing the structure and hence revealing the information. I mean, here I also give you an information that is a wave. We are basically studying a wave, right? A signal is a wave, nothing but rather than that. It's a wave. And wave preserves the very idea of oscillation within it, beneath it. We have already studied that that a wave is nothing but an oscillatory idea, and wave has the very structure of oscillation beneath it. So to study waves, we need oscillation, and to study oscillation, we need Fourier analysis. That's it. Now I told you one important thing, that a signal can be interpreted in elementary oscillations, combination of elementary oscillations. These are 1 to 3 are elementary oscillations, and this combination can be interpreted as a signal. Is this even true? Let's think about it. I mean, you have seen that in nature the oscillation is evident, and the x of t, which is the quantity that we observe in any signal, which is a function of time, is the quantity which is observed first through any signal. And realizing the elementary oscillations inside this structure, combination of elementary oscillation inside this structure, is very hard, almost impossible, because it hides the oscillation details inside. So the thing is it even possible, or can a complicated acoustic signal can be fully understood by expressing them in terms of elementary oscillation? Is the more precise question we need to ask. That if we think that a signal is made up of elementary oscillations, combination of elementary oscillations, so can a signal be completely understood if we categorize them as some of the combinations of elementary oscillations, which is not prettily evident from the x of t we imagine, or we get from the first encounter of a signal. So this thing which I said now, that a signal can be interpreted as combination of elementary oscillations, this idea is very engraved in the heart of wave mechanics. I mean, in QM you see that an unknown object, an unknown state, an unknown operator can be understood or can be well represented when we represented them in the form of known bases. Or even in mathematical physics or vector spaces, which we learn, there what we do is we represent a known object with the help of known bases. And what we are really trying to do is here that we are trying to represent the unknown signal with the help of known elementary oscillations on the known basis. And that pure oscillation can be termed as SHO, which I'll be discussing further, which is simple harmonic oscillation. So a complicated signal, complicated acoustic signal, can be represented as a simple harmonic oscillation, a combination of various simple harmonic oscillation with different frequency, different phases, which could act as our known basis, through which we could understand an unknown object, which could relate to a complicated acoustic signal. So now we understood what is we are trying to do in a signal. We are trying to identify the elementary oscillations here. I mean, we said that it could be a combination of different oscillatory, simple oscillatory processes, and it is based on a fundamental idea that an unknown object can be represented in a form of known basis. That's all. Okay. Now, what are these elementary oscillations? These elementary oscillations are nothing but pure oscillation, which is simple harmonic oscillation. That is our SHO. Now, if you don't know SHO, then you could refer to the PDF to understand better what is an SHO, what is a simple harmonic oscillation. I have given a brief detail about this in a PDF. You could refer it in the description. Now, if I want to describe SHO, it is nothing but like you understand a vibration of a guitar string, a vibration of atomic molecules when a sound wave travels. There the particles vibrate around the equilibrium position, right? So we could describe it by some mathematical description, which is of an SHO, that is x of t here will be the x of t, the wave, the simple harmonic wave, the simple harmonic oscillation. It is also captured through a microphone, and it will also have an x of t, a quantity which changes with time. So the x of t here will be A cos omega t plus phi or A sine omega t. See how I represented a phase difference here. Phi is the phase differences. Omega is the speed with which, I mean the you mean the angular frequency. It is the angular frequency that how rapidly the oscillation repeats itself. I mean the order. I mean this. If you consider this, then this happens, and after this one more happens. So this cycles after how rapidly this cycle repeats, that's is represented by omega. And phi, you know the phase, because a cos starts like this and a sine starts like this, so there is a phase difference between the two. So phi is at t equal to 0. What is the current circumstances of this wave or current circumstances of the simple harmonic oscillations? So this is the basic mathematical structure by which we can describe an SHO. And to understand what is important here is this signal, this acoustic complicated signal is comprised of such pure SHOs which we need to understand, because nature doesn't contain pure SHO. Nature is rarely composed of these perfectly pure oscillations. They are heavily, compact with this complex acoustic signals, and we need to break it down to simpler or elementary oscillation, which is our SHO, to study it basically. Now important thing we need to introduce here is the frequency. Why I use this term? You know what is frequency. Frequency is nothing but how many cycles is there in 1 second. In 1 second, how many cycles we do in a periodic motion, that is our frequency. Why is it important? Let me get this straight. We know in a signal, there are many elementary SHOs. They are added in a superimposed way. They are in superposition with each other. But think about this, that not all oscillation are identical. This oscillation we are referring to, they are not identical, right? I agree that they comprise of different elementary pure oscillations, but they are of same identical structure. I don't believe that. They might have different omega, they might have different phases. You agree, right? They might have different structures, different phase difference create this. So they might not be identical. And if they are not identical, what is the physical quantity that differentiate one oscillation from other? That is nothing but frequency. And because a signal is comprised of different oscillation, different pure elementary oscillation, we need to study frequency to understand the oscillations better. And when we understand the elementary oscillations better, we understand the physical structure of the signal. You get it what I'm saying? So you understand frequency, right? Yeah. So like frequency, there exists a period which is t, that is 1 by f. And very important thing, that a simple harmonic oscillation which could be represented by f, but it is not represented by f, but it is very well represented by omega, which is the angular frequency. Physicists prefer this quantity to represent all SHOs, which is a thing that makes it easier. If you want to refer why, then you could basically go down to the PDF and understand that. But we do this relation, that is omega equal to 2 pi f, and makes us to this familiar form we are pretty able with, that is a cos omega t plus phi, which describes an SHO. So with all of this, with this frequency or angular frequency, we could differentiate between oscillations which are not identical in a signal. And you are pretty evident that a complex acoustic signal or a sound wave can contain many frequencies because it contains many oscillations. So if it contains many frequencies, then you would simply agree with the fact that a sound wave is not a simple cosine wave. A sound wave is a combination of, a superposition of many cosine waves. So its oscillatory processes or its oscillatory modes would contain different frequencies. And due to that different frequency, we need to understand the frequency part of the oscillation more to differentiate between that oscillations, to basically understand the signal we are studying, the complex signal we are studying, to reveal its internal structure. So here comes the the central idea that the x of t, as we further discuss, this is incompetent to describe different kind of oscillation present in a signal. In a signal, what is the most mathematical thing we encounter first? That is x of t. And x of t, as it is in the time domain, it cannot differentiate between two different oscillation. And you know what? Two different oscillation is described by frequency. It is differentiated by frequency. So it is evident that x of t does not able to differentiate 2f or 2 omega. Two different f or 2 different omega, So two different oscillation is never be differentiated by the help of only x of t. We cannot realize by only realizing the x of t from a signal. We need a better mathematical framework. We need to convert this x of t to a better physical quantity through a mathematical framework to better get the idea of frequency or oscillation. I will rephrase it. हमें x of t को एक better physical quantity में convert करना पड़ेगा by the help of a mathematical framework which is called Fourier analysis, which I told you earlier. और इस Fourier analysis के मदद से जब हम उस x of t को, जो कि हमें सिग्नल से मिल रहा है डायरेक्टली, एक मैथमेटिकल वेरिएबल, उसको जब हम एक लेजिबल फिजिकल क्वांटिटी में कन्वर्ट करेंगे, उस फिजिकल क्वांटिटी का हेल्प करके हम वो फ्रीक्वेंसीज निकाल सकते हैं जो ऑसिलेशन से रिलेटेड है, जो हमें डिफरेंट ऑसिलेशंस को एक सिग्नल के अंदर जो है उन्हें एक्सप्लेन करने में हेल्प करता है. सो वी नीड दैट फिजिकल क्वांटिटी टू एक्सप्लेन सच कॉम्प्लेक्स acoustic signal which is comprised of different elementary pure oscillations but nothing but SHU. So we need Fourier analysis, we need x of t, and we need that other physical quantity to better understand different oscillation in a physical signal which we receive, because we need different frequency to differentiate those elementary physical oscillation. I think I am clear up to this. Okay, now let's suppose we have all discussed these ideas. Now, if we have a complex signal, if we have an x of t, how would we know that what frequencies it possesses? It's basically that, right? What omega 1, omega 2, omega 3 dash 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 it possesses. To know the overall elementary pure oscillation, its superposition it contains, the signal contains. It's basically, it will reveal its physical structure, right? Yeah. So how do we get the idea that what angular frequencies or what frequency does it possess? The basic idea from which we can get that is by comparing that quantities with the known signal. That is what we do in the basis, right? We compare this with this to get what is the quantity of that, what is the strength of that, contribution of that oscillation with that particular frequency. See, if we compare omega 1 with the unknown signal, we will get a contribution of this frequency, and that will be the contribution of that oscillation. If we compare omega 2 with x of t, we will get a contribution of that oscillation of frequency omega 2, and similarly. And the important thing is that contribution we see here has some specific details in it. Let's look at that. And the details is, So the details is, supposedly, if we see, when we possess an unknown signal, we have an unknown signal x of t, there is an unknown signal, and we want to compare many frequencies with this to get a contribution of each frequency to understand the elementary oscillation present. And suppose if the comparison is poor, the comparison between omega 1 and x of t is poor, suppose, that reveals that this x of t very lessly contains this frequency of oscillations. This x of t would not contain a frequency so much of omega 1, or it may, or the oscillation with angular frequency or the frequency omega 1 is completely absent in x of t. It doesn't have that elementary pure oscillation with frequency omega 1 in x of t. And if the comparison is strong, if omega 2 and x of t and the comparison is strong, that means it conformly guaranteed that this frequency's oscillation is evidently present in x of t as one of the elementary pure oscillation. Clear? Now, if you think about this, let me say that x of t is something like a sine omega t, right? And if I take cos omega t plus phi, something like this, as my omega 2, right? And if I compare this both two, you see, because there is a phase difference, these two will have very poor comparison. I mean, we are not still talking about the comparison part here, that how would we compare these two. But if we talk about the comparison only, then these two have a poor comparison because due to the phase difference. So evidently, it will give us that the oscillation with frequency omega 2 is evidently not present in x of t, which is a complete false thing. Because here the function differentiate, but we can see that, or it is a fair chance that omega 2 must be present in omega. But due to this phase difference or this function difference, we can see that the comparison directly becomes poor here. So to resolve this, we must do one thing, that instead of assuming that x of t is a sine omega t plus phi or a cos omega t plus phi, we directly state that x of t is something which is let it be, or I mean x of t is the unknown signal, but we could do such a thing that we take the known basis. I mean, this is a basis, right? The basis is getting compared with the unknown object here. So the known basis can be took in such a way that this sine, cos and phase difference is neglected. I mean, this thing is taken care of. And to do that, the known basis is taken as exponential functions. What? It is taken as exponential functions. Again, to know more specifically about that why we select the known basis which we compare with the unknown object x of t is taken as the exponential functions, you have to refer the PDF which I have given in detailed description there. But overall, you understand what due to the comparison factor which is immediately getting poor due to the poor representation of the function which differentiate due to the phase difference, we resolve this issue by solving that, by pretending or by taking that the known basis we considered here are exponential functions. Why? Because there is a very famous Euler exponential which we see and which we appreciate, that is e to the power I theta is cos theta plus I sin theta. You are very familiar. It is a remarkable equation which basically combines cos and sine into one specific expression as e to the power I theta, right? And if we take this exponential functions as our known basis, as a choice of known basis, then on comparing this, whatever sine or cos this function is, it will not be affected by the function, the choice of functions of the known basis, because with just itself the the choice of known basis, the function that we choose for the known basis, just the choice of the function will not lead to the poor comparison between them. It will really compare the omega and omega 2, omega 1, etc. The frequency part. It will really compare the contribution of frequency part, through which we will know the oscillation is present in x of t, or it is made of that x of t, or it is comprised of that x of t or not. Completely independent of the function part of comparison, which will be resolved by taking the exponential part. So we could basically describe our known basis as e to the power I omega t. And the omega will be the respective omega 1, omega 2, omega 3 and respectively, etc. All the frequency which we compare with the unknown x of t to get the contribution of each frequency to be a part of elementary pure oscillation in that unknown acoustic signal. That's it. Okay. So the thing about comparison will now become clear to you, that how we get this elementary pure oscillation or this oscillatory mode inside this unknown acoustic signal or the unknown waveform. How do we compare them, or how do we get the contribution out of them to know how this unknown waveform is made up of pure oscillatory modes or pure oscillatory processes or waveforms, and how this structure is formed through them. Let's understand what is that comparison. So let's develop an analogy to understand this. I mean, the PDF has a great detail on this, that how do we develop this analogy, how do we develop this comparison and understand how this Fourier analysis comes into play. But I'll give you this quick analogy to make you understand how this whole thing comes into play and how do we compare them to get the required contribution of the frequency or the required contribution of the oscillatory mode out of them, or out of the unknown signal or unknown structure. Let's go. Okay. So the analogy is, I mean, think of a spatial dimension where A and B are two vectors. Okay, A and B are two vectors with theta is the angle between them. So how do we get compare these two vectors? Like if you take the dot product between them, that is A dot B, that is AB cos theta, right? This is the obviously the, I mean, this is the magnitude, and AB cos theta is our dot product. What does this dot product do? Can you tell me? This dot product basically, I mean, it compares these two both vectors in doing this dot product. We basically compares these two vectors, that A vector is how much in the direction of B vector. Like if I take an example, suppose theta is 0 degree. This means that cos theta is 1, which means that A dot B is simply AB, which is a max value. And this max value suggests that A and B all completely overlap with each other. They superimpose with each other, or they are in the same direction. I mean, I could easily make a fair chance of comparison accurately between them. But if you think that if theta is 90 degree between them, that means cos theta is 0, which means A dot B is 0. That means A and B are completely at a 90 degree from each other, which suggests that A and B have no direct connection with each other. Knowing A doesn't guarantee you knowing B, because that direction is completely different. Likewise, if A dot B is negative, you could say that A and B are completely in different directions. So what is this dot product doing? It is basically it is comparing these two vectors here, that how they are related, or how one is related to another, in direction or component. Similarly, in the case of functions, there is a function called f and there is a function called g. Suppose both is related to time. So you can observe here that these two vectors are spatial, I mean, it's spatial quantities, I mean SPATIL, spatial quantities. I mean, it is dependent on x, y, and z, I cap, j cap, and I cap, k cap, and j cap. But the function, it is of infinite dimensions because it depends upon many points of functions. So when we compare two vectors, we use the dot product to compare them. I mean, to find one vector is related to the other with what quantity of component or what quantity of direction. But when we describe about the function, we don't use the dot product but inner product. I mean, it is the rule of vector spaces. We use the inner product, which is nothing but f comma g, the inner product sign, which is f of t, g of t, and dt. As you can simply see, the dot changes to an integration sign, which compares the two functions by using the inner product. Now, we know how to solve this inner product and get the contribution of f in g, which is basically what we are doing here. We are using this inner product to compare one function, which is a known basis, with an unknown function, with an unknown function, which is x of t, which is an unknown object. So we are basically doing what? That is representing an unknown object with the help of a known object or known basis to get the idea of the contribution of the known frequency in the x of t. This is our comparison, how we do it. It is by doing the inner product. Now, I think that the idea is not specifically clear when we understand it through mathematics, but when we understand it through the quantum mechanics, it is more clear. Let me tell you how. Okay. So, let me make you understand something very clear. That is, in QM, we have a unknown object, let's say psi. It is a state which is not known specifically. But there is some eigenstates which is already known, a basis which is already known, that is n and m. So if I want to find the contribution of n in psi, I mean if n as a eigenstate is n as a state is an eigenstate of psi or not, or m as a state is an eigenstate of psi or not, what should I do, you think? I should only do the inner product or the projection of psi on n, of psi on m, that is n of psi, m of psi. This will do nothing but simply tells us that what is the contribution of n in a state psi, or a contribution of m state, m eigenstate in psi state. Simply this, which you can clearly see that the inner product does compare a eigenstate, I mean a state, a known basis, this is a known, these two are known basis obviously, with an unknown object. And when we compare them, we indirectly find that this known basis or this state, how much is it contributes in the formation of the unknown state. This known state or known basis, how much it contributes in the formation of the unknown states. I think we are clear here. And through analyzing this analogy, we could basically do what? We compare our known basis or known frequency with the unknown signal, variable, which is x of t, to get the idea that that signal, how much it is made of elementary oscillatory modes or elementary pure oscillations. What are the oscillations it is made of? What are the oscillation it is superimposed with? I mean, what are the oscillation it is in superposition with? To understand that, or to get the idea that, we compare it through using the inner product rule. I think we are clear here. So you could directly say that e to the power I omega t is our known basis, and x of t is our signal information in the mathematical language. So if we need to find the contribution of a specific frequency signal or a specific frequency oscillatory mode, oscillatory mode, how much it contributes in the formation of the unknown structure or the unknown signal we do nothing but use the inner product between this. That's it, to find this. And if we write this in a more better way, because it is functions, we write it in integration form, that is e to the power minus I omega t x of t dt 0 to t. And here, my friend, you understand that this is nothing but the Fourier transform, which is not a formula but a basic representation of projection of the unknown state with the known basis, which will give us the contribution of the known frequency in the unknown structure. How much is the contribution of the known frequency in the unknown structure to identify the pure oscillation inside the unknown structure, the superposition of pure oscillatory modes inside the known structure. It will reveal that corresponding or the corresponding frequency which it holds just by taking the projection of the unknown structure with the known basis, which is done by nothing but inner product in the functions, and which is written in this form, which is nothing but the Fourier transform. So the Fourier transform is nothing but it is the contribution of known frequency in the given unknown structure of x of t. And by knowing that known frequency, we identify the pure oscillatory modes inside the x of t, which is pretty evident here, I think we are clear here. We understand what is the Fourier transform by doing this. And one of the most important thing I want to tell you that these frequencies, I mean to say that e to the power minus I omega 1 t x of t is compared once, then e to the power minus I omega 2 t x of t is compared, then e to the power minus omega 3 t x of t is compared. When comparing this all frequencies with x of t, that how much their respective contributions are. The respective contributions are in the unknown signal or unknown structures, these frequencies don't mix. They don't mix with each other. Due to what? Due to orthogonality. As the frequencies are orthogonal to each other. How they are orthogonal to each other? Do you want me to explain it? Let's do it then. Yeah. So, if you want to prove that they are orthogonal to each other or not, I mean, it is orthogonal or not. That is to I left it to for you to prove. I mean, it is just a homework, so a small given homework in this project that prove them that they are orthogonal. But for you, I will do a thing to prove them that they are normalized. I mean, not normalized, but they are orthonormal. Sorry. I will do one thing that for you, I will prove them that two frequencies, I mean two not, but the same frequencies are orthonormal. That means e to the power minus 1 omega t, e to the power minus I omega 1 t, these gives me 1. That means they are orthonormal. But the orthogonality part, that you have to prove that how you will prove that two different frequencies are orthogonal. Hence, they don't mix with each other. So let's prove this. So this is omega t. Sorry, omega 1 t dt 0 to t. So I can write this as this is so e to the power minus I, it simply cancel, you see. This is 1 dt from 0 to t. So this will give me t. And you could see that t is the most significant, I mean, it is the contribution. So if I take t as 1 second, then this will give me 1. So this is orthogonal. You can guess from this, right? So this is the reason why the frequency don't mix with each other. This is not the reason, but this is the reason that you have to prove yourself, that how they are orthogonal to each other. I think I'm pretty clear here how they are orthogonal to each other. Okay. I mean, this orthogonality part which I have left with you to solve, I mean, it is pretty much evidently given in the PDF. You could refer and solve it yourself to analyze how they are orthogonal to each other. I mean, everything is given in the PDF. You could just refer and do the things yourself to better get a grasp of everything. Okay. Okay. So we understood that we could basically find out the frequencies hidden inside the unknown structure or unknown signal or unknown acoustic signal just by doing the Fourier transform, which is nothing but the inner product of the functions, which we can do by doing the projection of unknown function with the known basis or the known function to get the projection coefficient or the contribution of the frequencies which is hidden inside the unknown structure. By that we can find out the frequencies present inside the x of t. In the x of t, we could find different frequencies present inside it just by doing this inner product or the Fourier transform we call in the formal mathematics language, which converts the time domain x of t to frequency domain, which is a very important idea. You need to realize that this converts nothing but the time domain x of t to frequency domain of x of omega. This is done by purely Fourier transform. That is nothing but a projection idea or the inner product between two functions. Got it? It is nothing but just comparison. Through that comparison, we figure out the contribution from each frequency, and throughout we get the different frequencies engraved inside the unknown structure or the unknown acoustic signal. Now we have done a very pretty job that we have identified the frequencies inside the unknown acoustic signal that indirectly reveals the pure oscillatory modes inside the signal. And when we have these pure oscillatory modes inside the signal, we already know the structure inside that signal. How that structure help us to understand the language. Now we'll get to the philosophical part of it, or rather technical part of it. Now the physics ends here and the computational part starts. So I will try to make you understand how this goes with the computational parts from right here. So let's get to it. Okay. So you have to understand something now, that in a computer, this x of t is not continuous. I mean, it is pretty clear that x of t, it is not stored as a continuous function in a computer. I mean, you know, in a computer, there is some discrete points through which the x of t can be stored. I mean, it could be stored in some endpoints. So here the continuous Fourier transform is not done. Here the Fourier transform done is called discrete Fourier transform. I mean, it is a signal processing part, so I will leave it here because it doesn't deal with the physics directly. I mean, it has some sampling rates thing, and by the help of sampling rates, you could divide that, this x of t or the measuring quantity of dependent upon time into some different endpoints. And according to that endpoints, you could categorize them and store it and find the discrete Fourier transform. You could specifically read in the PDF in detail, but as you understand that x of t is not continuously stored in the computer but in discrete form. You understand this? Okay. Now, when it is stored in discrete form, the important thing to understand is that you understand that there is so many points here. I mean, it is not continuous, but it is discrete in a very large space. Yeah. So there is a very large number of points. There is large number of points. I mean, x of t has large number of points in it. I mean, if I make a table, that table is very large according to t. For 1 second, for 2 seconds, for 3 seconds, for 5 seconds, or 0.1, 0.2, 0.3. I mean, according to the time, there are different values at a very high range, at a very large number of, at a very large number. It is a very large number of x of t. So when you have a large number of x of t and we do the Fourier transform here, we get the frequency. I understand we get the 400 hertz or 800 hertz or 1000 hertz. We get the number of frequencies here in x of t. That how much, which frequencies are present here. It is made up of which pure oscillatory mode frequencies. We get that here. It's simple, I know. Okay. But the problem here lies that because the x of t is so large, we don't get the perfect idea that, I mean, it is a signal, right? It is an audio signal. It is a sound signal from an alien civilization. So you don't get the idea that this 400 hertz to 800 hertz to 1000 hertz, it changes like this. I mean, the frequencies in the audio signal, it changes like this. I mean, the sound they are saying or the sound that is coming, the initial sound contains this frequency, then this frequency, then this frequency, or 1000, 800, 400, or this pattern. We are not sure about. I mean, जब एलियन बात कर रहा है तो इनिशियली जो वो बात कर रहा है उसमें ये फ्रीक्वेंसी है या फिर ये फ्रीक्वेंसी या फिर ये फ्रीक्वेंसी, और पैटर्न ये है कि पहले ये है देन ये है देन ये है, ये हमें क्लियर ही नहीं है बिकॉज वी आर ऑब्जर्विंग सर्च लार्ज नंबर ऑफ पॉइंट्स एट वंस. हम एक्स ऑफ टी ऑल्दो कंटिन्यूअस नहीं है पर उसके डिस्क्रीट पॉइंट्स भी बहुत ज्यादा है. तो हम इन डिस्क्रीट पॉइंट्स को जब एक साथ फोरियर ट्रांसफॉर्म करके एनालाइज कर रहे हैं अलग अलग फ्रीक्वेंसीज को, तो हमें उसका परफेक्ट ऑर्डर पता नहीं चल रहा है. आई मीन वी कांट एग्जामाइन द परफेक्ट ऑर्डर इन विच द फ्रीक्वेंसीज आर प्रोवाइडेड टू अस. हमें जो फ्रीक्वेंसी मिल रहे हैं वो एक परफेक्ट ऑर्डर में नहीं मिल रहा है. 400 के बाद 800, फिर 800 के बाद 1000, ऐसे नहीं मिल रहे हैं. ये भी हो सकता है फर्स्ट वे, सेकंड वे ये भी हो सकता है, या फिर 1000 के बाद 400 फिर 800. मेनी वेज पॉसिबल. यहाँ तो बस मैंने 3 फ्रीक्वेंसी लिखे हैं फॉर एग्जांपल, लेकिन यहाँ पे मल्टीपल फ्रीक्वेंसीज एक्सिस्ट कर सकते हैं एक्स ऑफ टी में, क्योंकि एक साउंड में मैं तो ये नहीं बता सकता ना कि ऑक्सिलेटरी मोड बस यही एग्जिस्ट करते हैं. देयर कुड बी मल्टीपल मिलियन एंड बिलियंस ऑफ फ्रीक्वेंसीज, पॉइंट्स पे भी आ सकते हैं. तो मैं ये ऑर्डर नहीं बता सकता कि किस साउंड के बाद कौन सा फ्रीक्वेंसी प्रिवेल करता है. सो हम क्या करते हैं इस चीज को फिगर आउट करने के लिए, कि इसको बेटर बनाने के लिए, मतलब तुम समझो कि सपोज इस फ्रेम में, मतलब जब एक साउंड सिग्नल आ रहा है तो इस फ्रेम में कुछ फ्रीक्वेंसी प्रेजेंट होंगे, जैसे कि 400 बस ले जाओ. इस फ्रेम में 400 और 800 बस प्रेजेंट है, जिसमें 400 प्रीडोमिनेट करता है, इसमें 600 प्रेजेंट ही नहीं है या फिर 1000 प्रेजेंट ही नहीं है. तो इस फ्रेम से मुझे पता लग रहा है कि जब उस सिग्नल का इस फ्रेम को मैं एनालाइज कर रहा हूं, इसमें मुझे बस ये फ्रीक्वेंसीज दिखाई, यू आर गेटिंग माई पॉइंट, कि मुझे बस ये फ्रीक्वेंसी दिखाई दे रहे हैं. नेक्स्ट फ्रेम में शायद मुझे 1000 प्रीडोमिनेंट लगे, तो मुझे एक ऑर्डर ऑफ फ्रीक्वेंसी पता चल रहा है कि किस फ्रेम में मुझे किस फ्रीक्वेंसी प्रीडोमिनेंटली पता चल रहा है. तो अगर मुझे ये ऑर्डर पता चल जाए कि एक ऑडियो सिग्नल में, इन ए ऑडियो सिग्नल, इफ आई recognize the order in which the frequencies are divided in the frame, I mean frame 1 कुछ sound, frame 2 some acoustic sound, frame 3 some acoustic sound, and I refer to that frequencies simultaneously, कि मुझे frequency correspondingly पता चल जाए कि उस फ्रेम के अकॉर्डिंग क्या क्या है फ्रीक्वेंसीज, then I can possibly say that I have gradually made a pattern. Let's understand it through an example. Okay, see, I have an x of t. मुझे पता है एग्जाम्पल से बेटर क्लियर आएगा. I have an x of t which has a many discrete points, और इन डिस्क्रीट पॉइंट्स को मैंने कुछ फ्रेम्स में डिवाइड कर लिए. सपोज 3 फ्रेम्स, 4 फ्रेम्स, 1 2 3 4. अब इन फ्रेम्स के अंदर मान लो कि ये पूरा स्पेसिफिक पॉइंट जो है ये है 40,000 पॉइंट्स का. आई मीन एक्स ऑफ टी कंटेन्स 40,000 पॉइंट्स. मान लो कि पर सेकंड ये गैप. आई मीन फर्स्ट सेकंड में कुछ एक्स ऑफ टी मिलेगा वैल्यू, 1 में कुछ वैल्यू, 2 में कुछ वैल्यू, सपोज 200, देन 150, लाइक दिस अप टू 40,000 सेकंड एंड सम वैल्यूज. तो इसमें 40,000 नंबर्स है एक्स ऑफ टी में. सो अगर मैं एक साथ सबका फोरियर ट्रांसफॉर्म कर दूंगा तो फ्रीक्वेंसी, आई मीन इट विल बी स्कैटर्ड, मतलब ऑर्डर वाइज नहीं मिलेंगे कि इस पार्ट में क्या फ्रीक्वेंसी प्रीडोमिनेट कर रहा था, उस पार्ट में क्या फ्रीक्वेंसी प्रीडोमिनेट कर रहा था. आई विल नॉट गेट द ऑर्डर स्पेसिफिकली. सो व्हाट आई विल डू इज, आई विल डू वन थिंग, दैट आई विल सेपरेट दिस फ्रेम्स. मान लो कि इस फ्रेम 1 में बस आई मीन 1500 नंबर्स आते हैं, और 1500 नंबर्स. इस फ्रेम में 8,000 नंबर आते हैं. आई मीन आई विल डिवाइड इट इक्वली कि हर फ्रेम में 1500 नंबर्स आ जाए सपोज. तो कितने नंबर्स होंगे, 40,000 बाय 1500 कर लो, उतने फ्रेम्स आ जाएंगे. और हर फ्रेम में मैं फोरियर ट्रांसफॉर्म अलग अलग लगाऊंगा. इन एवरी फ्रेम आई विल अप्लाई फोरियर ट्रांसफॉर्म सेपरेटली. दिस टाइप ऑफ फोरियर ट्रांसफॉर्म इज कॉल्ड शॉर्ट टाइम फोरियर ट्रांसफॉर्म, STFT. इट इज अ टेक्निकल सिग्नल प्रोसेसिंग टर्म अगेन इन इलेक्ट्रॉनिक्स, कि मैं शॉर्ट टाइम फोरियर ट्रांसफॉर्म लगाऊंगा हर एक फ्रेम में, टू ऑब्जर्व कि इसमें फ्रीक्वेंसी स्पेसिफिकली क्या क्या है, इसमें फ्रीक्वेंसी स्पेसिफिकली क्या क्या है. बिकॉज मैं टाइम डोमेन को फ्रीक्वेंसी डोमेन में कन्वर्ट कर रहा हूं ना, मेरे पास टाइम डोमेन वाला फंक्शन है. आई हैव द टाइम डोमेन फंक्शन, बट आई एम कन्वर्टिंग इट टू द फ्रीक्वेंसी डोमेन फंक्शन. So I will specifically apply Fourier transform in this frame, then this frame, then this frame, then this frame, and I will specifically get frequency predominant in this frame, frequency predominant in this frame, frequency predominant in this frame, and I will categorize them in a order or in a graph which is called a spectrogram. Let us understand how from a better detailed example between Rocky and Grace. Now let's come to the project Hail Mary example. Suppose this is my project Hail Mary example, okay, in which Rocky and Grace are talking. Rocky and Lyra and Grace are talking to each other. Now the physics part has completed. हमने टाइम डोमेन से फ्रीक्वेंसी डोमेन जंप कर लिया उन ऑसिलेशंस को समझने के लिए, उस अंडरलाइनिंग फ्रीक्वेंसीज को समझने के लिए, जो हमें बेटर आइडिया दे रहे हैं कि उन फ्रीक्वेंसीज को अगर हम समझ गए तो ऑसिलेशंस को समझ गए, जिससे फिजिकल स्ट्रक्चर को समझ गए. अब वो फ्रीक्वेंसीज जो है, वो ऑसिलेशंस जो है, हमें कैसे हेल्प करते हैं एक लैंग्वेज को समझने में, एक एलियन का. दैट वी आर ट्राइंग टू डू नाउ बाय द हेल्प ऑफ एन एग्जांपल इन project Hail Mary. Okay, let's do it. So when we are watching a conversation between Rocky and Grace, the important thing to realize here is that when Rocky is speaking, he is speaking in terms of x of t. ये माइक्रोफोन में कैप्चर हो रहा है ग्रेस. ओके, नाउ x of t को मैंने कन्वर्ट कर दिया किसमें, x of t को किसमें कन्वर्ट कर दिया, फोरियर ट्रांसफॉर्म में. ऑब्वियसली नॉट फोरियर ट्रांसफॉर्म, बट it is in frequency domain now by the help of Fourier transform. So what I did here is, जो रॉकी और ग्रेस के बीच में कन्वर्सेशन था वो x of t के फॉर्म में हो रहा था. रॉकी उसको x of t भेज रहा था उसके माइक्रोफोन में, पर ग्रेस को उसका लैंग्वेज समझने के लिए he needed it in frequency form, फ्रीक्वेंसी डोमेन के फॉर्म में उसे चाहिए था, x of ओमेगा के फॉर्म में. So he used Fourier transform. Now the important thing is to notice is that he doesn't use Fourier transform on whole of x of t. जो मैंने एग्जांपल पीछे दिया कि पूरे इस इतने बड़े रिकॉर्ड में उसने फोरियर ट्रांसफॉर्म यूज नहीं किया, इस पूरे लंबे एक्स ऑफ टी में उसने फोरियर ट्रांसफॉर्म यूज नहीं किया. ही यूजेस द फोरियर ट्रांसफॉर्म फ्रेम वाइज. ही यूजेस द फोरियर ट्रांसफॉर्म फ्रेम वाइज. व्हाट डू यू मीन बाय फ्रेम वाइज? द इंपॉर्टेंट थिंग इज यू टू रियलाइज दैट जो फोरियर ट्रांसफॉर्म उसने यूज किया उसको फ्रीक्वेंसी डोमेन में कन्वर्ट करने के लिए, उसपे से उसे मान लो कि फ्रेम 1 में 400 and 600 हर्ट्ज की फ्रीक्वेंसी मिली. ओके, ये उसको फ्रीक्वेंसी मिले. फ्रेम 2 में he got 400, 600 and 800 hertz frequency, and frame 3 he got 400, 600 and 900 hertz frequency. Any doubt up to this? No. Okay, आई मीन टू से दैट जब उसने, मान लो ये तीनों फ्रेम एक एक्स ऑफ टी में ही आते हैं, दिस थ्री फ्रेम इज कंसिस्टेड ऑफ वन एक्स ऑफ टी, एक एक्स ऑफ टी में ही है। देखो ये सिग्नल जो आ रहा है ग्रेस के पास माइक्रोफोन में, दिस वन एक्स ऑफ टी कंटेन ऑल दिस फ्रेम, all these numbers, all these codes. But the important thing is to realize that this x of t is broken into different frames to understand what frequencies are predominant in each of the frames. So इस फ्रेम में बस ये फ्रीक्वेंसी था, इस फ्रेम में बस ये फ्रीक्वेंसी था, इस फ्रेम में बस ये फ्रीक्वेंसी था। अब इन फ्रीक्वेंसीज के कंट्रीब्यूशन भी डिफरेंट हो गए बिकॉज फ्रीक्वेंसीज तो आइडेंटिफाई कर लिया, बट फोरियर ट्रांसफॉर्म बेसिकली करता क्या है, इनर प्रोडक्ट करता क्या है, दैट इनर प्रोडक्ट हेल्प अस टू अंडरस्टैंड how much is this contribution or how much is this coefficient, Fourier coefficient, how much is this contribution, how much is this, how much is this, how much is this, and respectively. So let's suppose कि 400 का contribution 90% था, 600 का 10%, here 400 is 60%, 600 40%, 30%, and this is 10%. Similarly, okay, so the important thing is to realize that after gaining this information, what will Grace do? Grace will make a spectrogram. What will he make? He will make a spectrogram. How does it look like? Let's see. So, here is my frequency. In the x-axis, I have the frequencies. Let's suppose this is 400, this is 600, this is 800, and this is 900. Okay. Now let's suppose this is my amplitude. In x-axis, I take my amplitude. I mean the strength, the contribution of the frequencies. So here I take some contributions. I don't mention it right now, but छोड़ दो इसको। और मैं कुछ यहाँ पे frames decide करता हूँ। This is frame 1, this is frame 2. I mean इस तरह से decide नहीं करते हैं, it will be difficult. Let's do it one way. Frames हम इसी तरफ ले जाते हैं। This is frame 1, this is frame 2, this is frame 3, this is frame 4. So you know that frame 1 में कौन कौन से आते हैं? इस तरफ एम्पलीट्यूड नहीं है, ठीक है, एम्पलीट्यूड को मैंने अभी रिप्रेजेंट नहीं किया है। सो फ्रेम 1 में 400 हर्ट्ज आता है एंड फ्रेम 1 में 600 हर्ट्ज भी आता है विद सम एम्पलीट्यूड 90 एंड 10 स्ट्रेंथ, ओके। एंड फ्रेम 2 में 400 भी आता है, 600 भी आता है, 800 भी आता है, बट 900 नहीं आता, इसमें ये दोनों नहीं आते। और फ्रेम 3 में, फ्रेम 4 नहीं है, अब तो 3 है बस, 400, 600 और 900 आता है। So this is a specific spectrogram he made कि उसने frequencies ले लिए, frames ले लिए और amplitudes ले लिए। Basically amplitude को इस पर draw करना थोड़ा मुश्किल है, तो I have shown a specific what do you say representation how the spectrogram is drawn कि basically frame 1 में कौन से frequencies present होंगे, frame 2 में कौन से frequencies present होंगे, and frame 3 में कौन से frequencies present होंगे। So by doing this, what Grace saw that, उसे ये मिलने के बाद कैसे पता चला कि उसका language क्या बोलना चाहता है। Let's suppose see that. With this, he also identified the observation he saw. मतलब जब रॉकी ये फ्रीक्वेंसीज बोल रहा था, मतलब वो जो लैंग्वेज बोल रहा था वो तो ग्रेस को समझ नहीं आ रहा था, बट ही अंडरस्टूड द फ्रीक्वेंसीज ही अटर्ड। मतलब उस लैंग्वेज को यूज करके, फोरियर ट्रांसफॉर्म यूज करके वो फ्रीक्वेंसीज को समझ गया हो कि फ्रीक्वेंसीज में क्या बोलना चाहता है। तो जब वो 400 और 600 बोल रहा था पहले फ्रेम में, वो अपने आप को पॉइंट कर रहा था। वो क्या कर रहा था? ही वॉज ऑलवेज पॉइंटिंग हिमसेल्फ। जब फ्रेम 2 में 400, 600, 800 बोल रहा था, तो खुद को पॉइंट करते हुए वाटर, मतलब खुद को पॉइंट कर रहा था, उसके साथ साथ वो ग्रेस को पॉइंट कर रहा था। और जब वो 400, 600 और 900 को, मतलब फ्रेम 3 में इस फ्रीक्वेंसीज को, मतलब जब अटर कर रहा था थर्ड फ्रेम में, उसी सेम एक्स ऑफ टी में जब एक फ्लो में बोल रहा था, वो खुद को पॉइंट कर रहा था, साथ साथ शिप को पॉइंट कर रहा था। तो इससे क्या क्या क्लियर हुआ? एक पैटर्न बना हमारा कि 400 और 600 जब वो फ्रीक्वेंसी अटर करता है, ही मींस ही पॉइंट्स हिमसेल्फ। दैट मींस कि वो खुद को पॉइंट कर रहा है। इसका मतलब ये है कि ही इज ट्राइंग टू से दैट आई और रॉकी, वो खुद को पॉइंट कर रहा है कि 400 and 600 means I, me, Rocky. He wants to say Rocky. And here, if we say 400 and 600 and 800, he want to say I, and he point to Grace. That means Rocky, human. I mean to say that he says Rocky and he says human. This is just an toy example, right? To understand the conversation between Rocky and Grace, कि practically वो चीज कैसे हो सकता था उस सिनेरियो में। तो जब वो 400, 600 और 800 बोलने की कोशिश कर रहा है, वो कर क्या रहा है कि वो खुद को पॉइंट भी कर रहा है, साथ साथ ग्रेस को भी पॉइंट कर रहा है। इसका मतलब वो रॉकी भी बोलना चाहता है प्लस वो ह्यूमन भी बोलना चाहता है, मतलब वो ग्रेस को पॉइंट कर रहा है मतलब ही इज पॉइंटिंग द स्पीशीज दैट ग्रेस इज, दैट मीन्स इट इज ह्यूमन, although he doesn't know what is a human, but he understand that he is a different species. So by uttering the frequencies 400, 600, 800, he wants to say that Rocky is pointing to a human. He wants to point a human. So this 800 frequency literally mean a human. So उसने figure out कर लिया कि 400 600 जब बोलता है that is Rocky or himself. He is pointing to himself. But जो जब वो 800 बोलता है तो वो human को point कर रहा है. And similarly जब वो frame 3 बोलना चाहता है तो क्या कर रहा है, 400 600 फिर से अटर कर रहा है, खुद को पॉइंट कर रहा है, रॉकी बोलना चाह रहा है और साथ में शिप की तरफ पॉइंट कर रहा है. सो मींस 900 रिवील दैट 900 फ्रीक्वेंसी रिलेट्स टू शिप, वो शिप को पॉइंट आउट कर रहा है. तो इससे एक बेसिक पैटर्न दिखा. जब उसने बार बार ये चीज रिपीट किया तो एआई ने मशीन लर्निंग के थ्रू एक पैटर्न जनरेट किया इसका कि 400 600 जब वो अटर कर रहा है उसका मतलब ये है कि वो खुद को पॉइंट कर रहा है, रॉकी को पॉइंट कर रहा है. ही इज telling that he himself is Rocky. And when he is uttering 800 frequency or 900 frequency, uttering means the voice signal he is giving, which is recorded through microphone of Grace. The frequencies he is pointing out or the frequency is uttering out, that means 800 means human and 900 means ship. So by understanding this whole pattern through machine learning and AI, we get a whole grammar of it, whole vocabulary, whole डिक्शनरी ऑफ द एलियन लैंग्वेज दैट रॉकी इज स्पीकिंग. एंड इस चीज को पैटर्न बना के एक स्पेशल डिक्शनरी बना के जब भी रॉकी कुछ बोलता है ही बेसिकली फिगर आउट ऑल द फ्रीक्वेंसीज इन इट. 400 600 400.01 450.62 800 600 1000 1200 1500 एनी फ्रीक्वेंसीज. और उन सब फ्रीक्वेंसीज को लेके मैच करता है कि कौन सा फ्रीक्वेंसी का पैटर्न किस वर्ड्स लेटर्स को पॉइंट करना चाहते हैं और उससे एक सेंटेंस बनाता है जो कि वर्ड फॉर्म में उसे दिखाई देता है कंप्यूटर पे. सो दिस इन्वॉल्व फिजिक्स व्हिच इज कन्वर्टिंग द टाइम डोमेन टू फ्रीक्वेंसी डोमेन टू अंडरस्टैंड द फ्रीक्वेंसीज इन इट. एंड दैट फ्रीक्वेंसीज हेल्प अस टू रिकॉग्नाइज अ पैटर्न बिकॉज जब हम कुछ बोलते हैं उस सिग्नल में उसके अंदर वो सेम फ्रीक्वेंसीज होंगे अगर हम सिमिलर चीज बोलना चाहते हैं तो. एंड व्हेन ही अंडरस्टूड दोस फ्रीक्वेंसीज ही अंडरस्टूड द डिक्शनरी और ही इज रेफरिंग टू द डिक्शनरी ऑफ फ्रीक्वेंसीज. तो उस फ्रीक्वेंसीज को लेके वो डिक्शनरी में पॉइंट कर रहा है जिससे वो एक ग्रामर बना पा रहा है पूरे एलियन लैंग्वेज जो रॉकी बोलता है. और स्पेसिफिकली वो फ्रीक्वेंसीज उसको अगर मिल गए, सपोज सोचो कि उसको 400 600 और 1000 मिल गए और 1000 पॉइंट करता है सपोज पानी को. सो वो कहना चाहता है कि मुझे रॉकी आई नीड वाटर, आई रॉकी वाटर. सो ही इज टेलिंग दैट through those frequencies in x of t that he need water. So इस तरीके से पूरा वो एक लैंग्वेज फॉर्मेशन होता है जिससे वो बात कर पाते हैं. This is a rough idea that how these two organism or these two species interact with each other through physics, through mathematics, through AI, through computation, and through whole bunch of science knowledge or physical laws that combines these two species together to bond each other, to bond through each other. मतलब ये जो मैथमेटिकल डिटेल्स है अंडरलाइनिंग ये उन्हें एक दूसरे के साथ बॉन्ड करने में हेल्प करता है. आर यू क्लियर नाउ? थ्रू दिस टॉय मॉडल की वो फ्रीक्वेंसीज को यूज करके कैसे एक पैटर्न बना रहा है, कैसे एक मशीन लर्निंग डेवलप कर रहा है, कैसे एक एआई से पैटर्न्स निकाल रहा है जिससे वो एक डिक्शनरी बना रहा है जिससे वो रॉकी को पूरी तरीके से समझ सके. नाउ इफ यू वांट टू अंडरस्टैंड द टेक्निकल डिटेल्स, द सिग्नल प्रोसेसिंग, हाउ इट इज डन, हाउ रॉकी एंड ग्रेस आर टॉकिंग टू ईच अदर थ्रू सैम्पलिंग रेट, नियस्ट थ्योरम, जो ह्यूमन का फ्रीक्वेंसी रेंज होता है 20 हर्ट्ज टू 20,000 हर्ट्ज, उससे ज्यादा 44.1 किलो हर्ट्ज में क्यों रिसीव करता है माइक्रोफोन इस चीज को. एवरी टेक्निकल डिटेल्स, एवरी टॉय एग्जांपल व्हिच आई मेंशन्ड, द फ्रेमिंग डिटेल्स, एवरीथिंग इज मेंशन्ड इन पीडीएफ इन वेरी ग्रेट डिटेल. यू कैन गो एंड लर्न इट ऑल योरसेल्फ फ्री इन डिस्क्रिप्शन. ये तो बस मैं आपको तरीका समझा रहा था कि कैसे आप इसको समझ सकते हैं. पर इफ यू वांट टू अंडरस्टैंड इट वेरी डीपली देन यू हैव टू आल्सो पुट सम एफर्ट. कुछ भी चीज ऐसे नहीं हो जाता ना. यू हैव टू रीड एंड गिव दोस एफर्ट टू अंडरस्टैंड दैट. आप जब एफर्ट देंगे उस चीज को लेकर देन यू विल फील एनलाइटेंड. आई जस्ट मेड ए कमेंट्री ऑन दैट नॉलेज. मैंने आपको फिजिक्स का पार्ट तो बहुत क्लियरली समझा था कि हम साउंड को क्यों करेस्पॉन्ड कर रहे हैं, हम ऑसिलेशंस में क्यों जंप कर रहे हैं, फ्रीक्वेंसीज में क्यों जंप कर रहे हैं, उनको कैसे फिगर आउट कर रहे हैं, फोरियर ट्रांसफॉर्म को एज क्वांटम मैकेनिक्स और एज इनर प्रोडक्ट कैसे रियलाइज कर रहे हैं, हाउ वी आर डीलिंग विद द कंट्रीब्यूशन। एक्चुअली फोरियर ट्रांसफॉर्म दिखाता क्या है, वो बस कंट्रीब्यूशंस देता है दो सिग्नल्स को जब हम कंपेयर करते हैं, तो एक अननोन सिग्नल को एक नोन सिग्नल से, और उससे हमें उसका फ्रीक्वेंसी मिलता है, जिससे हम नोन सिग्नल्स की मदद से एक लैंग्वेज बना सकते हैं, एक पैटर्न बना सकते हैं, जिससे हम एक मतलब क्या बोलते हैं, एक एलियन लैंग्वेज को समझ सके बेसिकली। सो दिस इज व्हाट वी आर डूइंग। सो आपको अगर ये पूरा डिटेल से समझना है हाउ दिस प्रोसेस ऑफ सिग्नल प्रोसेसिंग इज गोइंग ऑन, यू कैन गो ऑन द पीडीएफ एंड डू इट योरसेल्फ। आई मीन इट इज वेरी एविडेंट, यू कैन डू प्रीटी मच इट। ऑल्सो मैं इसके एंड में ट्राई करूंगा कि एक कंप्यूटेशनल मतलब आपको आइडिया दे दूं कि कैसे ये जो हमारे एक्स ऑफ टी है और जो सिग्नल है, मैं स्पेसिफिकली अपना एक सिग्नल रिकॉर्ड करूंगा, मतलब अपना एक साउंड रिकॉर्ड करूंगा मेरे लैपटॉप में, एंड थ्रू पाइथन कंप्यूटेशन आई विल शो यू दैट हाउ दैट साउंड इज ब्रेक इनटू फ्रीक्वेंसीज, मतलब कैसे वो फ्रीक्वेंसी में ब्रेक होता है। आई विल शो यू द ग्राफ। और जब वो फ्रीक्वेंसी को मैं एक एआई में भेजता हूँ जो मशीन लर्निंग के थ्रू, मतलब जब रॉकी बार बार उन पैटर्न्स को, मतलब उन सिग्नल्स को भेज रहा है, बार बार उन चीजों को बोल रहा है, सो कैसे पैटर्न रिकग्नाइज कर रहा है और कैसे उसको फिगर आउट कर रहा है, उसके बाद तो आप समझ ही सकते हैं। तो वो कैसे ब्रेक करना है, दैट कैन बी डन थ्रू कंप्यूटेशन, एंड ऑल्सो यू कैन ट्राई टू डू।
So, hey people, now we are going to do a computational journey on the thing I talked about. That was when we record a signal, we get the x of t, that is the measurable quantity in time domain, and we'll convert this to frequency domain, which the machine learning and AI wants, and it recognized the pattern as I talked about, and made a whole dictionary or language out of that signal by which we can understand Rocky or the alien we are talking to. I mean, basically the physics tells us that we need the frequency amplitude graph, right? From the time domain graph. And which is the most important thing. After that, the AI takes over, recognizing the patterns of the voice. And through machine learning, we could go further and do the whole communication thing. So we are doing it in Python and using the VS Code, and the simple, the idea is we will record our voice right now in front of you live, and after recording that voice, I will first of plot the x of t graph, which is the waveform one, the simple time domain, and after that, I will plot the frequency graph. I mean, frequency domain one, frequency amplitude. And after plotting both those graphs, you understand that the frequency graph we will send to the AI to generate the machine learning part, which I will not do here because that's the most computer science engineering part, which I am not aware of, or that's a very different part from the physics which we are talking right now. Although we could do it, we could make the AI understand things and recognize the things, the weird things we say through the signal. But that's not the important part we are studying here. That's the computational part or the AI thing part or the software engineering part. You could do it yourself. That basically relies to the computer science. But I'm going to talk about the physics part of it. That why we need the frequency signal, or not why, but the frequency signal we talked about, that why we need it. We are going to see it through the computational journey, that it is very much possible to do it as accurate as possible through this computational, to the computational physics. I mean, it's not just only the maths, but we could specifically record a voice and convert it into whole frequency domain. So let's see. So this is my code for recording my voice. As you see, this is for duration of 10 seconds. Basically, I could tweak it to 5 or 7, or I'm basically taking it 10 seconds with the sampling rate. To learn more about the sampling rate, why is it more than the maximum hearing limit of a human, that is 20,000 hertz, that is the frequency, you have to refer to the PDF to learn more about it because it is the technical details and the computer science part. And this is the recording basically, and it is named at myvoice.wav, which I'm recording right now. So without further ado, let's record it. So I'm recording it right now. Uh, that's it. All right. Yeah, let's record. Hello guys, I hope you are enjoying this video. So am I enjoying this? And we're basically doing the computation part and blah blah blah. That's it. I mean the 10 seconds. It's over. Yeah. So we've recorded it. Now let's hear it, which you have recorded right now. So this is it.
Hello guys, I hope you are enjoying this video. So am I enjoying this? And we're basically doing the computation part, and blah blah blah. That's it.
So yeah, we recorded it. Now let's get the waveform part very quick. And the waveform part, as you know, this is the x of t we are plotting. I mean the time domain part with the, I mean the time with respect to the amplitude. Time in the x-axis and amplitude in the y-axis. As usual, this is the signal I'm reading. I'm in using the read function through the Python libraries. I'm reading this my voice, which I'm again plotting that. Okay, plotting the signal with the title x of t. Without further ado, let's plot it. Okay, waveform dot py. All right. So, yeah, as you can see, the thing which I spoke just now, you can see it on the graph very clear. This is what I spoke right now, guys. Yeah, the amplitude part with the sample number or the time, basically with the points, and it looks pretty much like a complicated graph or a signal graph. Yeah, this is the basic signal which you are getting through the receiver, not the language part or the words part or the vocabulary and anything. First doesn't come the, I mean, the history or the socio geopolitics and anything, guys. The physics is the first part, which you could see now. It's the basic electronics part, the signal part. Yeah. So this is the x of t. Now, let's convert it into the most important part, that is the frequency domain part, without wasting any time. So let's get to it now. Yeah. So this was the graph you saw. Okay. Let's minimize it for further reference. And now is the very important code, that is the Fourier transform code. Yeah. So you already know this is my voice.wav, which I saved. I'm reading it again in the signal and I'm taking the signal as float. And here is the signal I have subtracted from the mean value for simplifications. And this is the most important part in the code, which is nothing but Fourier transform. FFT means fast Fourier transform. Also, I'd like to give you a remark that you could also do it not using these libraries but manually. That will give you an idea how the Fourier transform is going on as formula in directly in the code. You can write it directly without using this library. This libraries just make the things easier for you. Yeah. So this FFT is giving me the contribution or the strength of the frequencies, the respective frequencies from the signal. Yeah. So at the same time, I have to plot the frequencies also because I need the frequency and amplitude or the frequency and strength graph. Yeah, because Fourier transform gives me the strength of the corresponding frequency, which we just through the math, saw through the maths. Yeah. So this is giving me the Fourier transform or the strength, and this is giving me the corresponding frequencies. After that, I need it positive, so I have this given this declared these things you can see. And after that, I plotted it the frequency versus the strength graph in x-axis and y-axis, and I have kept it into the, I mean, audible range, that is 20,000 hertz for a normal human being. I could basically decrease it to 3,000 or 4,000 something. Let's decrease it to 5,000 for time's sake. And I saved it, and let's plot it now. So let's plot it. Okay. I need to close it, guys, to plot another graph. Okay. Basically, let's plot it now. Okay. Why did I do this? Okay. FFT face.py. All right. Now, what we see is the actual graph of what I spoke in frequency domain. You could see it is between the amplitude and frequency. It is from not 20,000 hertz, but it's 5,000, but it's okay. I will change the text. Yeah. Now, if I plot that. Yeah, now you could see it is the frequency spectrum is from 0 to 5,000 hertz, corresponding to the time domain. It is the frequency domain graph. And this is the most important graph that the machine learning or AI needs to get the whole communication thing going on, the whole meaning thing which we are going to understand. It is the most important part to get to that part. I mean, to get to the literature, the culture, the translation, and everything, the meaning inside it. We need this graph very much. This is the most important part which you are seeing through your eyes right now for alien language communication, which Grace needed from Rocky to understand his voice. I mean, humans are so intelligent, right? You could see it yourself in front of your eyes. Ah, that's beautiful. Yeah. Okay. So, also a remark right now, this thing is done in whole time framing things. I mean, this whole x of t is broken into small frames, and that frames is done individual Fourier transform itself and plotted in the same similar manner using an array, which is much more complicated than this simple graph, which I am taken as small x of t. I mean, think of it like that we got a whole message of some 10 minutes or 20 minutes but I've just breaking it into 10 seconds, and for that 10 seconds, I have performed the Fourier transform for you, and that 10 seconds give us this reveals this frequency. For individual frames, we could basically plot individual graphs, and we could send it to the AI, and for through the machine learning, it could break the patterns out, and we could basically get the language out and the meaning out. That's it. So was important, and you could see the graph right now in front of you guys. Okay, so I think I'm clear here. Okay, thank you.
We were fortunate enough to do pretty well decent amount to understand the physics of Fourier analysis. That how do we break an unknown signal into known form through Fourier analysis, frequencies, oscillations, and many more things. The underlying physics part we did it in very detail, but the signal processing, the electronics part, although I have done it in detail in PDF, but here I just explain you the process how it is done. But if you want to understand the basics, discrete Fourier transform formulas, how it is done, how do you take the k values and all the things, and the short time frame Fourier transform, I mean the frame breaking, how it is breaked, and those things, and the sampling rate and everything, the intrinsic details about that, the signal processing details, how it is done, and the AI and machine learning thing. I have mentioned it in PDF in very detail. You can go and just look at it and read it once to get a better idea of how to do it precisely, and it will be a good intuition for you to develop how these things are done. See, I mean, you cannot go into details and understand it very much in uh, brilliant detail at once. You have to put in the continuous effort one by one in a specific manner to go inside it. I mean, yeah. So you could go and read it once. It is very important to read that. After listening to this, you will get a better idea that what mathematical structure means, and also that orthogonality part I have gave you to solve and prove it yourself. You can do it if you want. I mean, if you want. If you don't want, then you could get an idea that how it is done through this video and through that PDF. Uh, Many things can be done. I am also not completely into it. I have not completely goes into the details of it. I have not made that AI model or machine learning thing, which is a computer science thing. But I have left the thing open to work in future. I mean, work never stops, right? So मुझे ये concept बहुत interesting लगा. I find that this concept was very interesting to understand that how a alien talk with a human actually, how it is done actually through basic physics and mathematics, that is the Fourier transform, which I find very interesting. So I try to do with utter honesty and everything. And because I know I will fail in this video, I've done very big mistakes. कहीं पे connection जो explanation है वो click नहीं करेंगे. The explanation might feel very boring at some stuff, or it will be not precise. Somewhere wrong also, I accept that. And for that specific reason, I have made the PDF that you can go through and read it and correct yourself and comment it yourself that this is wrong. You have done the wrong thing, or you have said the wrong thing, and I'll happily admit it, because humans make mistakes, errors are evident. Also, when we translate something from an alien, we could make mistakes. But Grace learns from that, and he better it every time, recognizing better patterns and understand Rocky, both through the information he is getting by understanding the physical structure and also emotionally in the movie. You should watch Project Hail Mary. It is a very great movie, and you will, I mean, you will be emotionally invested in it, and also the physics part of it, the science part of it. It is very beautiful. I mean, the visually is also movie very beautiful. So watch it in as big screen as possible if you have. I mean, a big TV or phone also you can watch anything. But appreciate the little things we see around. That's the whole motto of this video. The whole motivation around this video is that let's appreciate the things we see around around us. I mean, there are many beautiful things around us, right? And I find it fascinating that such intrinsic thing. I mean, look, this is a very small thing in movies. They talk to aliens like मैंने पहले मेरे जिंदगी में सबसे पहले कोई मिल गया देखा था उसमें आई मीन जादू चलाता है दे टॉक थ्रू इम्प्रेशंस आई मीन कुछ कुछ सिंपल इम्प्रेशन से वो लोग बात कर लेते हैं देयर इज नो मेंशन ऑफ सच थिंग्स बट जब मेंशन होता है देन वी कुड अंडरस्टैंड दैट हाउ इज इट डन एक्चुअली आई मीन इट इज वेरी फैसिनेटिंग टू सी कि कैसे हम एक एलियन लैंग्वेज को ह्यूमन लैंग्वेज में कन्वर्ट कर लेते हैं इतने इजीली just by noticing some mathematical details inside it, some physical structure, some physical nature like sound signal, electromagnetic signal, anything, and we do it very easily and understand civilizations from far, far away, extraterrestrial civilization, which is very interesting. So that was the whole motto of this video, to make you believe that the things we see around us is very interesting and we could at least give an honest attempt to understand them. And if we could, then at least help other people understand that if they are not able to, or they are not, driven enough to find that questions or the hidden questions. I mean, जैसे देखो, मुझे जब कुछ चीज पता चलता है तो आई एम वेरी हैप्पी एंड एक्साइटेड टू गिव इट टू द होल वर्ल्ड. आई डोंट कीप इट इन माई सेल्फ. उस तरीके से मेरे अंदर का नॉलेज डेवलप नहीं होता. when some people will करेक्ट मी, और जब मुझे करेक्ट करेंगे किसी जगह पे अगर मैंने कोई गलती की होगी, तो आई विल फील वेरी हैप्पी टू गेट करेक्टेड एंड इट विल मेक मी एज अ बेटर पर्सन. और मेरा नॉलेज ग्रो होगा, उसमें से मैं फोरियर एनालिसिस को और बेटर तरीके से समझ पाऊंगा. एआई लर्निंग, मशीन लर्निंग एंड एवरीथिंग, दिस पैटर्न रिकग्नाइजेशन, आई विल गेट ए very far idea of it. मतलब एक better idea मिलेगा मुझे उससे. So the whole video is based on a single thing that spread your knowledge as much as possible to educate anything and everything to everyone. In that way we will grow as a society. We will grow as a greater human being, as a greater species in this whole universe. That's it. That's all we do. We can't do great things in a small amount of time, but we can do small things which lead to great things uh, time by time. Yeah. So I'm not very great person or any great physicist or anything, just a student of physics, curious by the things I see around and I do in my life, that is physics. I am a physics student, you know. No, yeah. So I get fascinated by it. That's all. And if you enjoyed the video, you can like it, you can share it as much as you want. uh, yeah, we will keep on making this kind of video in the future always, and also the short films, and the best of we could do. That's it, man. If the video was somewhere fast or somewhere blurred, or the information was transcended to you in some wrong manner, you could always refer to the PDF down below, or freely comment it if you know better, or if you have a better understanding of the things I told you. And always welcome to the criticization and everything I have in the video. Thank you everyone to being till the end, and see ya. Yeah.